All right, greetings mathematicians. Let's take a look at our table of contents. Today we're going to practice with unlike mixed numbers. Keep in mind we've only really done adding and subtracting, so that's where we're going to be. And as far as the exact location, we're going to be on page 9 left and 9 right in your notebook. If you need to pause to get the title put in, go for it. You may have a different date. I'm pre-recording these. If you need to pause, pause. Otherwise, stick with me. All right, and I had a couple of runs at this one. Made a few errors. Let's look at the title together. Unit 1, Lesson 9, Solve or find the answer with unlike mixed numbers. When we're talking about unlike, we're talking about the denominators. Where they do not match. Our objective: I will solve problems that include adding and subtracting mixed numbers with unlike denominators. Read it with me. I will solve problems that include adding and subtracting mixed numbers with unlike denominators. All right. And our key vocabulary today is going to be the word borrow, or I'm sorry, ungroup, which really means borrow. For example, if I had, let's go with a 3-digit number. If I had $121 and you borrowed, let's say you took 17 away. Let's look at that problem. And using that standard algorithm, can I take 7 from 1 easily? No, I cannot. I have to borrow 10, because this is a base 10 problem. I have to borrow 10 from my 2 or my 20. That turns into 10. My 1 turns into 11. 11 minus 7, 4. 1 minus 1, 0. Bring down. We end up with 104. In this scenario, when you borrow, you're always borrowing 10. And you're always borrowing 10 because this is base 10 math. So base 10, say it with me guys, base 10 math. And the difference is, with fractions, when we're talking about fractional math, we borrow the value of the denominator. And this is one idea that we really need to get into our head. We're going to borrow from the denominator. And so we can see this better, I've got a sample on the next page. Let's take a look at the top of 9R. Now I have a few of my little Post-it strips. If you have these strips, they'll help you. Otherwise, you need to draw 5 shapes that are all the same exact size. So for this example, I'm going to say we have 2 1/2. And this example is going to be 1 3/4. So what I need to do now is I need to make my visual model match 2 1/2. So clearly I have 1, I have 2, I need half. So I'm going to fold that up and fold it back, do a quick tear. I now have 2 1/2. Now keep in mind that because my fraction says 1/2, I need all of these pieces to be halves. I need a half, a half, a half, and a half. All right, so I've got 1/2, got 1/2, got 1/2, got 1/2, and 1/2. So if you want to bring it back to a previous lesson, how many total halves do we have? 1, 2, 3, 4, 5 halves. So 5 over 2. All right, let's turn this into 1 3/4. So 3/4, I need 4 equal pieces. And they're pretty close. Not my best work. And then let's continue on. So each one of these is a quarter, a quarter, a quarter, a quarter. And remember, I have one whole, and now I need 1/4, 1/4, 1/4. And I don't know how well I'm going to rip this one, so I'm just going to fold it and tuck it under. So I have 2.5. I have 1 3/4. If I bring these two numbers together, if I bring them down, let's bring these two down. Let's do this vertically. Let's say, first off, we are subtracting. So let's take our bigger number, 2 1/2, and let's subtract 1 3/4. Let's look at the problem. Can I take 1 away from 2? Yes. 2.5 is clearly the bigger number. 1 3/4, it's not quite 2. So I can take this whole thing away from just the whole number. Now, I have to include the fraction. Look at your fractions. 3/4, 1/2. I'm going to have to do something, right? I'm going to have to get equivalent fractions and then do something with that. So how do I make this a fraction? Is this a change one or change both? Do I need to change both denominators to get an equal denominator, or just change one? That's right, if you guys said change one, I could use a multiplier, times 2, times 2, and create 2/4. So I could say that 2 2/4, right? And let's go ahead and make this reflective. Let's change that to 1/4, 1/4. All right, and this would have to turn into 1/4, 1/4, 1/4, 1/4, etc. So let's look. Can I take 3 away from 2? No, I cannot. So I need to borrow. On the previous page, we borrowed 10 because that was base 10. For this problem, we are talking base 4. And the reason being is the fraction tells us how many pieces we borrow. So we need to borrow 1 whole 4/4. We need to borrow 4/4, and we need to combine it. We need 4/4 plus 2/4. So we need to borrow 4/4 plus 2/4 and rewrite it as 1 6/4. We add our numerators. So we keep our 1 whole, we borrow 4/4, we add it to our 2/4, we get 1 6/4. So let me bring that down. 1 6/4 minus 1 3/4. Let's see if we can do it. Can we take 3 away from 6? Yes. 6 minus 3 is 3. Keep the denominator. 1 minus 1. What's the answer? 0. So the answer to this subtraction problem is 3/4. Now, you will have to find equivalent fractions, and if the smaller total number has a bigger numerator than the numerator you're taking away from, you're going to have to borrow. You're going to have to ungroup. Say it with me. Ungroup. We're going to take the amount that the fraction tells us from one of the wholes and pull it over. So we have successfully ungrouped. All right, mathematicians, you have some workbook pages that align with this. On page 21 and 22. And you have the homework book, page 17. This is extra work for my class. I will have some Prodigy questions loaded for you that you must do. This one you must do. This one you may do. Or if your parents tell you. All right, Huskies, have a great day.